All right, welcome to today's lesson. Today's lesson has been sponsored by Rihanna. So let's go ahead and get right into it, guys. This is just like implicit derivatives. The only difference is that we're taking the derivative with respect to time. So let's go ahead and get started. Example 1. Assume that the radius of a sphere is differentiable function of t, and let v be the volume of the sphere. Find the equation that relates dv dt and dr dt. That's only because volume of a sphere only has two variables. It's related to the radius. So volume is 4/3 pi r cubed. So we're going to take the derivative of this sphere with respect to time. So dv dt is equal to 4/3 times 3, 4 pi r squared, and I took the derivative of r with respect to time. And there it is. That's it. So now we're at this one, letter B. And it says, assume that the radius r and height h of a cone are differential functions of t, and let v be the volume of a cone. So find an equation that relates dv dt, dr dt, and dh dt. All right, volume of a cone is pi over 3 r squared h. That's volume of a cone. What rule do I got to use on this one? Product. And if you think about it, it is product with change because of the DRDT. I think it's easier to leave the pi over 3 factored out. Or I don't know, actually they're both the same. You don't have to factor it out. You can leave it. No, I'm gonna factor it out for now. Because I'm gonna do a factored form anyways. So dv dt equals pi over 3. And then first, times rid of the second, plus second, rid of the first, 2r dr dt. So I would probably write it like this, guys. Pi over 3, and then r squared dh dt plus 2 hr dr dt. And there it is. If you want to distribute the pi over 3, you can. You guys ready to do a problem? What's up? Yeah, how are they all related? How are all three of them connected? They're all connected by this equation like this. Does that make sense? So the question was, when they asked to find an equation that relates dv dt, dr dt, and dh dt, what does that mean? It just wants to know how all three of those connected to each other. All right, here's an example. I think this is coming from UH. It says a spherical snowball is melting in such a manner that its radius is changing at a constant rate. So that means dr dt is some constant number. We're going to find what that number is in a little bit. Decreasing from 21 centimeters to 10 centimeters in 30 minutes. There it is. So let's see what that is. 21 centimeters to 10 centimeters. So that's a difference of 11 centimeters in 30 minutes. At what rate is the volume of the snowball changing at the instant when the radius is 3 centimeters? R equals 3 centimeters. Okay. A snowball is, by definition, a sphere, not a perfect sphere, but let's assume that we're talking about a perfect sphere. And they want to know at what rate is the volume changing. Cool? Or not cool? You guys look scared. Okay. So volume equals 4/3 pi r cubed. dv dt equals 4 pi r squared dr dt. I'm going to plug everything in. 4 times pi times my radius, which is 3, square that, and then negative 11 over 30. I'm going to multiply all that together, guys. I'm going to use Desmos. So here we go. Let's use Desmos because that's what we've been doing all year. Don't worry, I'm going to share it, guys. Share, Google, there we go. And then Desmos, it's on my favorites. Math Tools, Scientific Calculator. And let's see, what do we have again? 4 pi. You know what? I want it in terms of pi. So I'm going to clear it. I'm going to clear the pi so I can have the answer in terms of pi. 4 times 9, because that's 3 squared, times negative 11 over 30. Okay, so there it is. So I put a pi next to it, by the way, negative 66 pi over 5. So here's the exact answer. Negative 66 pi over 5. And I need units. Oh, sorry guys. This time the class let me know that you guys couldn't see it. Negative 66 pi over 5, and I need units. Cubic centimeters per minute. There it is. If you're wondering, is it really cubic centimeters per minute? Yes. The radius was in centimeters. When I squared it, that was square centimeters. The rate, dRdt, is in centimeter per minute. Centimeter squared times centimeters, that's centimeters cubed per minute. Does all that make sense? Yeah, Kana? Are you cool? You're not sad? Okay. Are you happy with all this math? A police cruiser approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? Okay, we need a picture, guys. We need a picture. So let's see. Approaching a right angle intersection from the north. Okay, so here is my cop car. Here are the lights. And it's going south, so this cop car is going this way. And let's see, when the cruiser is 0.6 and the intercept car is 0.8 miles to the east. Okay, here's the bad guy. Bad. And he's 0.8 miles to the east. And here's a right angle, because the right angled intersection. And this is 0.6. And actually, you know what? You should not label, because as soon as you label them, that means that they're stuck. So you should use letters, Y and X, because they're moving. Okay, so let me stop to make sure that that makes sense to everyone. The X distance is moving and the Y distance is moving as well. So as soon as you put a number, that means it is no longer moving. That means it is static. It's stuck. Does that make sense to everyone? Okay, so you put letters. Anything that is moving, you put letters. So since I have a right angle, guys, I think it's perfect for a triangle. There it is. I'm going to call that Z. All three of those variables are moving. All three of those. Now, here's what I know. I know that they want, when the cruiser is 0.6 miles north of the intersection, so Y is 0.6. So this is the problem. They want to know when Y is 0.6 and X is 0.8. And let's see, they give me, what is this 20 miles per hour? It's a rate of change. Is it dx dt, is it dy dt, or is it dz dt? Perfect, it's dz dt. Look, with the radar, it says, the police determined with radar that the distance between them and the car is increasing at 20 miles per hour. That is dz dt. And then if you want to put units so you can know where you're at. All right, so what am I missing? To solve this question, I need to figure out, what do they want? What is the speed of the car? They want to know how fast this guy is going, the bad guy. How fast is this guy going? All right. So if I want to know how fast that guy's going, doesn't that mean, what do they want me to find then? Perfect. Find dx dt. That's what you're going to find. I already know how fast the cop car is moving. They told me he was going 60 miles per hour. So that is dy dt. So everything that I know, I'm going to write over here. And since I'm going down, I'm going to say that's a negative. Because look at the grid of how I wrote it. Is that okay with you guys? Yeah, Kana? You okay? Okay. There's one thing that I'm missing. I'm missing letter Z. Can I figure out what letter Z is? Yes, Pythagorean Theorem. Z equals 0.6 squared plus 0.8 squared, which I think is 1. 36 and 64, 64, 74, 84, 94. Yep, that's 1. Z's 1. 0.6, 0.81, 681, 6810. Okay. Are we okay so far, guys? All right, we're ready. Can you guys think of a relationship? Oh, sorry that I made that. There we go. Can you guys think of a relationship that binds X, Y, and Z together? Pythagorean Theorem. X squared plus Y squared equals Z squared. So I'm going to take the derivative of all three of those with respect to what? T. 2x dx dt plus 2y dy dt equals 2z dz dt. Oops, that's a t, not an x. And then look, I got everything, guys. I got x. I don't have dx dt, that's what I'm looking for. I have y, I have dy dt, I have z, I have dz dt. So let's plug in and let's see. If you want to cancel out the 2's, you can. It doesn't matter to me. Do you guys want to cancel out the 2's? Okay, let's cancel them out. So here we go. What was x? 0.8? 0.8 times dx dt, which was, oh, that's what we want to know. Dx dt plus 0.6 times dy dt, negative 60, equals 1 times 20. Okay, 0.8 dx dt minus 6 times 6 is 36. So this is going to be 36 equals 20. 0.8 dx dt equals 36, 46, 56. And then all I got to do to get it by itself is divide by 0.8. I don't know. Let's use Desmos. Looks like it's pretty fast. Desmos. What did I get, guys? Was it 0.8? He's going 70 miles per hour. Oh, that's pretty fast. He's going 70. Well, we'll find out right now. A hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment, the rangefinder's elevation angle is pi over 4. Do not work with degrees. Always work with radians. Pi over 4 is 45 degrees, but we don't want to work with degrees, guys. We want to work with radians. And the angle is increasing at a rate of 0.14 radians per minute. All right, so let's see. Let's draw a picture of what we have. So here's the ground. And let's see, it's a hot air balloon. So here's my hot air balloon. And I'm going to say that's the center of that balloon there. And here's my rangefinder. I have some angle. That's the height. Let's see, the angle is increasing at a rate of, and this is the right triangle there. The hot air balloon is rising straight up from a level field and is being tracked by a rangefinder 500 feet from the liftoff. Okay, this is 500 feet. So whatever is static, you can write that number down. If something is moving, do not write a number because it is moving. Does that make sense? All right. So let's see. We're gonna write what we know on the side at a moment. So here's the moment. What moment is it? They're talking about the moment when the angle is 45 degrees, and then the angle is increasing at a rate of 0.14 radians per minute. So d theta dt is 0.14. Are we okay so far, guys?
Yes.
Okay. So here's what we got to do. We got to figure out a relationship between the angle, between h, and between 500. Is there a trig identity or trig? Yeah, which one? Tan. So we're going to write tan of that angle is equal to h over 500. They want to know how fast the balloon is rising. So that is dh dt. So I'm just going to multiply by 500, guys, to get the h by itself. I guess you don't technically have to, but I am. And then I'm going to rewrite it. I'm going to say h equals 500 tan theta. All right, since I want dh dt, because that's what I want, how fast is the balloon rising? So since I want dh dt, I'm going to take the derivative with respect to time. So dh dt is equal to 500, leave it alone. What's the derivative of tangent? Not everyone at the same time.
Secant squared.
Secant squared. Am I done, or is there something missing? The derivative of theta, d theta dt. Chain rule, guys. Now you can plug it in. So now we have everything we need, guys. So 500 secant squared pi over 4. And I believe that was 0.14. No, you don't need a calculator for this. Here comes your pre-cal. Not even extreme pre-cal, guys. Just a little basic pre-cal. Baby pre-cal. So pi over 4 is right here. And look, they're even being nice by giving you pi over 4. Both coordinates are square root of 2 over 2. So secant's a reciprocal of cosine. So we're really looking at that one, but it doesn't matter. Both are the same magnitude. So the reciprocal of square root of 2 over 2 is 2 over square root of 2. I'm going to square that dude, and I'm going to multiply by 0.14. So let's see, 500 times 2 squared is 4. Square root of 2 squared is 2. 4 divided by 2 is 2. Sorry there. So let's see, 500 times 2 is 1,000. And then I can just count how many decimals I need to move. 140 feet per minute. Yeah, that sounds about right. Feet per minute. How do we feel? We feel okay? All right. Here we go. This one. Let's see. Let's see if we can understand the idea first here on this. It says water runs into a conical tank at a rate of 9 cubic feet per minute. So this is obviously how much volume is going into something. So that's dVdt. 9 cubic feet per minute. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. Okay, those two things are not changing, so you can write 5 and 10 for that. How fast is the water level rising when the water is 6 feet deep? Okay, let's see if we can get a picture of this. So I have a cone. That's a nice cone. And this height, that height, they told me, is 10 feet. So that's not changing. And on the base of this here's the base, this is what you consider the base here. That is 5 feet. So whatever's not changing, you can write in there. You can put the numbers in there. And then I have water in this tank. So let me see if I can illustrate the water. Yeah, that looks pretty good. Does that look like water? I'm impressed. I don't know why I got a D in art. Look how beautiful this art is. That's a true story, guys. I really did get a D in art. Let's see. Let's see. How fast is the water level rising? Okay, so I obviously need to know dHdt. I don't know what that is right there. And I do not, do I know what R is? The 10 stands point down, has a height of 10 feet and a base of radius. How fast is the water level rising when the water is 6 feet deep? I know what H is. Okay, so there it is. You guys ready? So volume of a cone. Well, this thing's not calibrated right. That's fine. Volume of a cone is pi over 3 r squared h. We did that earlier. We're going to take a derivative now. So I'm going to write, we're going to take the respective time. So dv dt equals, we're going to factor out the pi over 3 there. Yeah, they did give us a dv dt. They were looking for dh dt. How fast is the water level rising? You okay or no? First times root of the second plus second times root of the first. I'm going to fix it a little bit, guys. I was going to put 2RH, but I just decided to leave it as 2HR. All right, let's see what I have and let's see what I don't have. I have the height. I have indirectly, I have the radius. I have dv dt. I want to know what dh dt, so this is what I'm looking for. And I do not have dr dt, but I can get it. We're still okay? All right. So how am I going to get those values? How am I going to get the R and the DRDT? Well, here's how I'm going to get it, guys. It's not calibrated, guys, so that's why it's a little off here. Do you see that triangle in green? We all took geometry. That triangle in green is similar to the triangle in blue. Because we know it's similar, it just changes by a scale factor. Do we see that? That's cool, right? I know that this distance here is 5. I know that this distance here is 10. It's perfectly safe to write that in there because that's not changing. So let's see. 5 over 10 is to R over H. Do you guys see how I got that expression there? So now I can say 10R is equal to 5H. And I guess if I'm trying to find divide by 5, H is equal to 2R. Do I want to take a derivative here? I kind of feel like I want to just plug in what R is in terms of H. No, it doesn't matter. You know what? I want dRdt. So let's not go that route. Let's go R equals. Divide by 10, divide by 10. R equals half of H. dRdt is equal to 1/2 dH dt. Are we still okay? Guys, are we still okay, guys? All right.
Yes.
Here's what I'm gonna do. You could get DRDT, but I want to have everything in terms of DHDT. So I'm just gonna plug that in right there. And if I do that, here's my new equation. dVdt equals pi over 3 r squared DHDT plus, now look, check it out, guys. There's a half DHDT. The 1/2 and the 2 go away. So I'm going to have HR DHDT. Does everyone see what I did there? Now all I need is the R, and I already have it. Chavez, what do you mean you already have it? Well, yeah, we already know what H is. H is, what was H again? No. H was not that. H was 6 feet. So I can just plug in 6 right there and get R. See? So 5 times 6 is 36. Divided by 10, is R 3.6? It looks like it is. Did I do that right? Yeah, 3. Oh wait, no. Yeah, you're right. It should be 3. How did I get, oh, it's 30. Man, making mistakes all over the place. Yeah, 5 times 6 is 30, and I said 36. What the heck? Yeah, R is 3. All right, we got everything we need, guys. Here we go. dVdt 9. So 9 equals pi over 3. 3 squared, so that's 9. The HDT plus H. What was H? 6. 6 times 3. 18. The HDT. 9 equals pi over 3 times 27 DHDT. And I guess if you want to combine the 27 and the 3, I would probably get rid of this. So what I would do is multiply by the reciprocal. So 27 over pi equals 27 DHDT. And those 27s cancel out. So DHDT is equal to 1 over pi. Nope. DHDT is equal to 1 over pi. And I need units. Feet per minute. I added the 9 and 18. 8. Oh, I did 9 times 3, which is 27. You see right here? I just multiplied by the reciprocal. And 3 over 5 times 3 over 5. 9 times 3 is 27 over 5. And then I'll just divide by 27, divide by 27, 27 cancel out. And we got 1 foot per minute. 1 over pi feet per minute, not 1 foot per minute. Excuse me. You still okay? All right. So there it is. I thought it was all right. Wasn't too bad. And then I put it in here. Is there another way to do the example 5? So read example 5, Godinez, just so you can know what we're talking about. So yeah, there is. There is another way. There's always another way. This time I made the water nice and smooth. All right, and this distance here from the water, that's your H. This is your R. Since you want dH dt, you could have just replaced everything from the very beginning in terms of just H. So we could have said, again, the same thing, the same trick as last time. We could have said 5 is to R as 10 is to H. Are we okay so far? And then we could have said, let's see, we could have said 5H equals 10R. And what did I say I wanted to do? I wanted to replace the R. So divide by 10, divide by 10. So R is 1/2 of H. And put that in for there. Volume equals pi over 3 half H squared. You know what? Since I'm squaring it, I'm going to write it as H over 2. H over 2 times H. So pi over 3, that's a 3. H times H is H squared. 2 times 2 is 4. Finally, I have pi over 12 H to the third power. If I did the first one right, we should get the same answer on both of them. We're going to find out. We're going to find out if I did it right. I feel like I did. All right, dV/dt. Hey, hold on. Oh no, I did it right. dV/dt. 3 times pi, so it's, I guess 3 pi over 12. Well, I'll reduce it in a little bit, guys. H squared dH dt. So dV/dt is equal to pi over 4 H squared dH dt. I already know what H is. I already know what dV/dt is. 9 equals pi over 4 6 squared dH dt. 6 squared is 36. 36 divided by 4 is 9. So 9 equals 9 pi dH dt. Look how beautiful this is, guys. Oh my God. Oh, that sounded, okay, sorry. That happens from time to time. 1 over pi feet per minute. Did we get the same answer? Did that one look a lot simpler to you? I think it did. I think it looked simpler only because we have one variable, but it's the same. Well, we had to take the derivative, but we had to do with respect to two variables. See, we had, what? You'll catch up right now. In a little bit, miss. All right, how do we feel? Let's all come back,